Okay. When you're talking about classifying numbers, it's important that we understand how to read a Venn diagram, which is what this is. We have to understand that if it's in this group, whole numbers, which is really where our learning starts. Our learning starts with whole numbers. We learn 0, 1, 2, 3, 4, right? And as we learn more about numbers, we learn about the opposites of those, which are our integers. Not only does it include 0, 1, 2, 3, 4, but it also includes -1, -2, -3, -4. And as we continue our learning about numbers, we learn about rational numbers, which we said on Friday was anything that we could represent as a fraction. In other words, if it's a repeating decimal, if it's a terminating decimal, if it's a mixed number, I can represent it as a fraction. Even if it's an integer or a whole number, it's still what? It's still rational. In the whole set of real numbers, there's two classifications. They're either rational or they're irrational. In other words, not rational. And the only thing that fits in this not rational category, the most common one is pi, and then the other ones are these square roots that don't come out exact. You'll notice in here it says the square root of 4. Why is that a whole number? Because the square root of 4 is 2. And I really recommend that right next to where it says square root of 4 on your chart, that you put equals 2 so that you understand why it's in there. So you don't get confused. You should be able to look at a chart and decide and be able to answer this type of question. Is every rational number whole? Is every whole number rational? Yes. The innermost group, whole numbers are, every whole number is an integer, but not every integer is a whole number. Every whole number is rational, but not everything that's rational is whole. Everything that's whole is real, but not everything that's real is whole. Not everything that's real is rational. Because real also includes what? Irrational. Notice irrational is kind of a subset that's unique. It doesn't have much in it. And it doesn't have anything else listed as far as categories, does it? Anybody think we're going to learn more than about real numbers when we're doing math? Or do you think this is the end of where you're going to go with numbers? There's actually another set of numbers completely separate from real. Do you know what they're called? Okay. A lot of you have real friends, right? Anybody have the other kind of friends? No, what are they called? They're called what? Imaginary friends, right? There are imaginary numbers. And you'll eventually learn about those as well. Imaginary numbers are square roots of negatives. Because a square root of a negative would mean what two numbers multiply together and would give you a negative result. Well, can I take a negative times a negative to get a negative? Can I take a positive times a positive to get a negative?
Is a negative square root irrational?
A negative square root is fine, but the square root of a negative doesn't even fit in this category. In fact, on a calculator, if you put in a -4 and take the square root of it, it's going to give you an error. Okay? So, that's because you put in the square root of a -2.
That's impossible.
Okay. Everybody understand the categories? All things that you've talked about. So we're going to talk about how to figure out what categories these are. A baseball pitcher pitched 12 2/3 innings. What classifications can I put this in? And we need to include them all. It is rational.
Irrational.
Okay. I'm going to tell you, if it's rational, it can't be what? Irrational. That's not possible. They're two completely unique groups. If I'm looking at rational and real, it's real, it's rational. The next category in to look at would be, is it an integer? Is it an integer? No. That's all the classifications that I can put with that particular number. The next one's a little bit different, because what didn't they give you?
A square.
They gave you what? The area of what? A square. And they're asking you about the side of the square. How do you find the area of the square? Right? It's S squared, the side squared. What can I put in place of the area? 10. What's the opposite of squaring something? So the side is equal to the square root of 10, which is a little bit more than 3. Okay? Well, classifications. It's definitely irrational. If it's irrational, it definitely eliminated rational, integer, and whole. But what else is it? It's also real. Do you understand how to classify them? We good? Tell whether the given statement is true or false. Please don't stop there. Explain why. All rational numbers are integers. All rational numbers are integers. True or false? False. Sometimes you can give very easily what's called a counterexample. Counterexample is just an example that shows something is false. Well, a counterexample in this case would be any fraction that's can't be simplified. 2/3 is rational, but it's not what? But it's not an integer. That's why this is a false statement. Some irrational numbers are integers. True or false? False. I can't think of a counterexample for this one. But irrational is a completely different subset of real numbers. Right? It's completely separate. There isn't a single number that's inside of irrational numbers except irrational numbers. It's a completely different group. So, not just true or false, but why? Okay? We good? This one says identify the set that best describes. So when you're looking at a Venn diagram, the best description would be the innermost group that you could put it in. They could all be described as what? Real. But would that be the best description of one? No. One could be described as rational, but would that be the best description? One is an integer, but would that be the best description? One is whole. You want to go to the innermost group that it fits in to give the best possible description of the number. So, the amount of water in a glass as it evaporates. What if a third of a cup evaporates? Is it whole? It's definitely not irrational. It's definitely measurable. Rational in this case would be the best description. Because it is a measurable amount, it would be an exact figure, not something that is non-ending and non-repeating. It would be a measurable amount. And it would be between however much you started with, however much you started with and 0. It can't get down to more than what? It can't get below 0. Okay? The number of seconds remaining when a song is playing displayed as a negative number. And if you said an integer just because it has negative in it, this would depend on the display. How many people have a stopwatch on their watch? There's going to be a couple people that do. When you're using a stopwatch, does it show just seconds or does it show more than that? It shows tenths of seconds, hundreds of seconds, doesn't it? Would it then be an integer? What would it be then? It would be rational. Okay? So make sure that you're explaining why you chose your answer. Mm-hmm. Really? Okay. Like I said, it depends on the display. Mine goes, I think, to hundreds of seconds. Okay?